Good. So at this point, after we have sort of a basic understanding of what variables are and a basic understanding of, how we can plot the, association, or how we can plot how two variables are related to each other, we can start to talk about different types of variables. Because knowing the types of variables will help us to uh, um, understand or visualize more complicated relationships among variables. Okay, it's a very important topic. So when we talk about different types of variables, there are two ways to think about the types. We can say, well, we can classify variables into different types. First of all, based on um, what values they take. Or we can classify variables into different types based on their use, right? What functions they have. So let's first of all talk about how we can classify variables based on the values they take. First of all, we have categorical variables. So categorical variables simply means or simply refer to variables that can only take discrete values. Examples include our biological sex, our race, our ethnicity, and in many cases, our party affiliation. So, you know, let's say we use this variable as an example. Well, first of all, this is a variable because it can take two values, at least among humans. Among non-human animals, it's possible that they have a third sex. But anyway, we're talking about focusing on humans here. Um, in most cases, 99.9% of the time, a person is either a male or a female. In other words, this variable biological sex can take two values. Now, these two values, we call them discrete values because they don't overlap. They are two separate entities. Let's call them this way. They are mutually exclusive, meaning you're either a male or a female. There's no middle ground. I mean, again, in 99.9% of the time, right? Um, there's no overlap between these two values, and it doesn't make any sense at all to place these two values on any kind of scale. Right, this is scale. You could place male here and place female here, or you could place female here and place male here, but that doesn't make any sense. That doesn't mean anything, right? There's no way to place two discrete entities on any kind of scale or continuum that implies some kind of continuity. Because in nature, at least among humans, there's no way that you can move, well, unless you perform some procedure, right? But naturally, there's no way for humans to move in any kind of direction from one sex into a second sex. So in this sense, we say that you know these two values are discrete. They're discrete values. Now you may say, hang on, what about race? Certainly we have Caucasians, white people, and at the same time we have African Americans. So we have, you know, African Americans here, right? Or Asians, Asian American, doesn't matter. What if a Caucasian mom, or a Caucasian person, a couple, they're from different races. One is Caucasian, the other is African American. They got married and they have a child, and that child is of mixed sex. Sorry, not mixed sex, mixed race. My apology here. Okay. So this kid here is mixed race. Now I say, aha, don't they have overlap here? Because this sort of the middle state, or middle state between a white person and an African American person. But still, right? Once we have this person right here, half white, half, African American, there are still separate categories of people, right? Once this child is born, there's no way, genetically speaking, under the current state of science, that you can naturally move from a mixed race person into a Caucasian person or into an African American person, despite that you have one parent from this category and the other parent from that category, right? So again, these three values of this variable race, they are non-overlapping and they're non-continuous and they're mutually exclusive, right? You can claim that despite my, mixed race ancestry, I consider myself as white. Well, that's a different matter. That's your self-perception. But genetically, you are different from a white person. So again, we call these values, discrete. Well, lastly, you can easily reason through our last example, right? Party affiliation. You're either Democrat or Republican, or in some cases you have independents. In most cases, on most issues, Democrats disagree with Republicans, with independents, in the middle, right? The middle of the roaders. Again, these people, they're mutually exclusive, right? They're non-continuous, so they're discrete, right? So that's why we say that these variables are categorical variables. They have values, male, female, white, African Americans, Democrats, Republicans, that belong to different categories. That's why we call them categorical variables. Okay? Oops. Let me erase all my drawings here. Okay, so when I'm erasing my drawing here, I'm almost there. If we have categorical variables, then it sort of makes sense that we have what we call continuous variables. Continuous variables are also very easy to understand. It simply means, right, variables will refer to variables that will take values that will form a numerical continuum. So these variables, right, are in direct contrast to categorical variables in the sense that the values of these variables, they, very much overlap. They form a continuum. Okay? It makes sense, in other words. to place this variable on the scale and arrange their values in order. And in a very technical sense, all these values, they're so dense that you can imagine that different values are infinitely close to each other, right? So in this sense, we say they form a numerical continuum. Examples. Again, these are just some typical examples of continuous variables. I'm sure you can think of others, right? So income is a very typical, almost I would say a true continuous variable, because we can easily arrange all the values of income on a continuum ranging from, you know, $0 to $0.001 all the way to 99.999 to $100, right? So you see 99.999 is very, very close to 100, but still it's not 100, right? So as we add more nines to this number, you will get infinitely closer to 100. In other words, these 2 points, 99.99999, is very, very close and almost touches upon the point that denotes 100. They're so close that we consider the space between these 2 points infinitely small, such that, you know, when these 2 points join by other points who are similarly very, very close to each other, all these points form sort of a continuous continuum, a continuous scale that does not have gaps, right? So in this sense, we say income is indeed a true continuous variables. Well, attitudes is an interesting case because you can easily say that attitudes actually are discrete variables, because you will say, well, in my, conception, I think attitudes have only two variables. You either disagree with an issue or you agree with an issue. You are very correct if you think that way, right? Because disagree is definitely very different with agree, or disagreeing very different from agreeing, and definitely these two values are not overlapping. There's no way that these two overlap with each other, and they're mutually exclusive. You cannot disagree and agree on the same issue at the same time. So you think about attitudes in this way, then of course you will categorize attitudes, into categorical variables. But for many reasons that we don't have time to discuss here, scientists, they sort of think or treat attitudes similarly to how they treat income. They think, well, actually, our attitudes are also, you know, appropriate, can be appropriately placed on a continuum ranging from, let's say, 1, that is, I strongly disagree with an issue, to, well, I start to sort of move in the direction of agreement, but still I quite firmly disagree. Now, 3, well, I only slightly disagree with this issue. 4, now have a neutral position. And once I get past 4 and move on to 5, I become slightly in agreement with an issue, and all the way to 7 that I very much agree or totally agree with, the issue. So in this sense, scientists think that, well, attitudes can probably be treated as a continuous variable, the way that we treat income, right? There are a lot of debates on this. You don't have to agree with me or agree with scientists on their way, on the way they treat attitudes. But I'm just telling you that it is possible. It is theoretically possible to think attitudes as a continuous variable? Well, physicality, the same case, right? You can say, well, I think physicality is a categorical variable because you're either weak or strong. But other people might disagree with you. They say, well, you can move from very, very weak to kind of weak to slightly weak to slightly strong and all the way to very, very, very strong. So in that sense, physicality is a continuous variable. It also works. It also makes sense, right? So, but anyway, right? That suggests, whether a variable is a continuous variable or a categorical variable. Sometimes, not always, depends on how we see them. For example, here you can never say that a biological sex is a continuous variable. It has to be categorical. Race, similarly, party affiliation, 99% of the time, you would not be able to, convince an editor by arguing that party affiliation is a continuous variable, right? So these are pretty much set, but there are cases in which there's room for argument, and that's part of just doing science. It's all natural. All right, actually, we just went through this, right? Some variables can only be categorical, because there's no in between middle of the road state between the two values. But some variables can be either categorical or continuous for reasons we just discussed, right? If we treat physical strength, for example, as categorical, we'll say someone is either strong or weak. But if we treat it as a continuous variable, we can start to assign, numbers to them. 1 smaller than 2, 2 smaller than 3, and we imagine, right? We think as if people, they differ in very, very finite ways, in terms of their physical strength. All right, so that's just a cautionary note, so to speak. All right, so previously, just now, we talked about, variables in terms of their values and how we have different types of variables depending on what values they take. Now let's talk about, different types of variables depending on their function. So function simply means use, right? Once we say that, well, the function of a desk is to support, a person when when the person sits, we're talking about, its use. Similarly, right, we can describe variables depending on how we use them. So, the first kind of variable that we have, once we focus on their function, is predictive variables. As the name itself implies, right? Predictive variables are variables that predict another variable. In some cases, it also means that variables that would explain a second variable. Later on, we'll also talk about causality, right? Causal relationship. So in a causal relationship, we have cause and effect, right? We have cause, that results in some kind of effect. So we'll say that this will also be a predictor variable because that's the variable that predict the effect, or that's the variable that explains the effect, right? In terms of how the effect occurs, right? So you can imagine then if we have, predictive variables, then we'll also have outcome variables. So outcome variables, very straightforward, right? There are variables that are predicted, variables that are explained, or variables that represent effects. All right? Um, again, let me present to you or introduce you to some kind of convention here. Later on, we'll talk about different types of research designs. And actually, in lecture one, we talk about two different types of study designs with surveys, and we have experiments. So it turns out that when you are conducting a survey study, it is usually the case that you will use words like predictor and outcome variables, right? But in experiments, you will call predictor variables as independent variables, and you will call outcome variables dependent variables for reasons that we'll discuss later. But for now, just remember essentially, essentially, predictive variables and independent variables are the same thing. You can draw they're the same thing. And outcome variables essentially are dependent variables. They are again the same thing, right? They're just different terms or different concepts used in different contexts. So just bear in mind that difference here. Okay. Okay. So exercise time. I know we all love that. What I'm doing here. Oh, okay. The purpose of this exercise is to identify, from the following claims or sentences, which is the predictor variable and which is the outcome variable. Okay? So I'll give you a few seconds to think about it, or if you would like, right, you can hit pause this clip, and start to think about it. In each claim, in each sentence, there are two variables, and invariably there will be one predictor variable and one outcome variable, and your job is to identify which is which. Okay? Well, let me have some water. While you think about it. Okay? Alright, so let's imagine that you have paused the clip and you're ready. Because it's recording, it doesn't make sense for us to wait for too long, otherwise the file will become very big. Okay, so I'll give you now the answers. In the first sentence, level of income explains why some people are happier than others. The predictor variable, as I'm sure that all of you have no difficulty identifying, is level of income. That's predictor, right? Because we have the keyword here, level of income explains, right? Because the definition of a predictor variable is the variable that predicts, that explains, okay? So that's our predictor variable, and the outcome variable is happiness, right? That's our outcome variable. So our second sentence, excessive drinking negatively impacts health. So here the predictor variable is the amount of drinking, right? Because excessive is an adjective, it describes how much one drinks. So, this is the predictor variable, right? An outcome variable, of course, is the degree of health, how healthy you are. That's outcome. Easy. Lastly, GPA depends on how easy a subject is and students and how diligent you are, how hardworking you are. So here, this one is a little tricky, and I lied a little bit when I said, in each sentence there are only two variables, because here there are actually three variables. That's the first trick. The second trick is this sentence is framed differently from the previous two sentences. So that means you cannot simply, solve this problem by saying, oh, this word appeared first, so that must be the predictive variable. Well, if you think that way, you're wrong in this case, because this sentence obviously means what explains GPA, or what predicts GPA. It is the easiness of a subject. That predicts your GPA. At the same time, how diligent you are will explain whether you have a higher or lower GPA. So both easiness of a subject and diligence, these two are the two predictive variables here. And we have an outcome variable here. Okay? So be careful, right? Make sure you understand the definitions of outcome and predictive variables, and don't rush once you see questions like these on the exam, right? Make sure you understand what the sentence means and then make a decision. It's not very difficult, just be careful. Okay? All right.